Hello everyone, welcome to another video. In this video, what we are focusing on is geometry and trigonometry multiple choice questions. Question number 1. In the isosceles triangle shown above, the value of x is. Now, one thing that we know about isosceles triangle is that it has two equal sides, as these strokes suggested, and two equal angles. So this angle right here is going to be 35 degrees. So we can say that x degrees then is going to equal to the sum of the angles in the triangle, which is going to be 180, minus the sum of these two angles. So it's going to be 35 plus 35. And then x degrees is going to equal to 180 minus 35 plus 35. That's just going to give us 70 degrees. And 180 minus 70 degrees, that's going to leave us with 110 degrees. So x degrees here is equal to 110, and that option is going to be C. To our second question, in the right angle triangle above, 9/15 is, so we want to look at 9/15. We have two angles in question. We have x and we have y, right? Now, what we need to do is to label our triangle according to either x or y, right? So let's label it according to y. If we label our triangle according to y and we draw a straight line to this side, it takes us to BC, where BC is going to be opposite to angle y degrees, which means that this 90 degree, if we draw a line going there, it takes us to 15. So 15 is going to be the hypotenuse, which means that this side around here where 9 is going to be the adjacent side. Now we have information for the adjacent and the hypotenuse. So which ratio that reminds us of? That ratio should remind us of cos of an angle. We know that cos of an angle is equal to adjacent over the hypotenuse. Now, what's the adjacent in this case? That would be y degrees. So it would be cos of y degrees is going to equal to the adjacent length, which is 9, divided by the hypotenuse length, which is 15. So clearly here you can see that 9/15 is equal to cos y. So our answer for this problem is going to be D. So our next question, it says the image of a point K, -3, 4, under a cancellation 5, 2 is, what do we know? We know that the object, right, plus the cancellation vector must equal to the image. What do we know? We know the object, so we can write the object in column format. So the object here is K. So that in column format, that would be -3, 4, plus the cancellation vector, which is 5, 2. And that should equal to the image, which is I. When we add these, add corresponding elements, and -3 plus 5, that will give us a +2. And 4 plus 2, that will give us 6. So we can see that I here is equal to 2, 6. But you must always remember that this is a point. So we're trying to find K prime. So K prime then is going to equal to 2, 6. All right, as a point. So in the triangle PQR, not drawn to scale, PQ is 13 centimeter, R is 5 centimeter, PR is X centimeter. And angle PRQ is 90 centimeter. Then X is just going to be 12, right? This is just one of the Pythagorean triples, the 13, 12, 5 triangle. We can even circle our answer from now. But how would you work out this quickly? Just apply the Pythagoras Theorem, which says that the square of the hypotenuse, which is 13 here, 13 squared, is equal to the sum of the square of the other two sides. So it's going to be x squared plus 5 squared. What is 13 squared? 13 squared is 169 is equal to x squared plus 5 squared is 25. From here, now you want to solve for x squared. So you can subtract 25 from both sides. So it's going to be 169 minus 25 is equal to x squared. 169 minus 25, that will leave you back with 144, which is equal to x squared. Remember, you want x and not x squared. So at this stage, you take the square root of this side and take the square root of that side. This square will cancel the square root symbol, so you're left back with x. And the square root of 144 will give you 12. Okay? In a triangle ABC, angle A equal x degrees and angle B equal 3x degrees. What is the size of angle C? Best thing to do, make a sketch. So we have a triangle, right? And our triangle is A, B, C. What do we know? We know that this triangle is not drawn to scale. We know that angle A is x degrees. That's what we know. We know that angle B is 3x degrees. And they are asking us to find angle C. So angle C, right? Angle C has to equal to the sum of the angles in the triangle, which is what? 180 minus the sum of the two angles that we know. What's the sum of the two angles? That's just 3x plus x. Can this be simplified? Yes, it can. So this can be simplified as just 180 minus 4x. So angle C is equal to 180 minus 4x. Which option is that? That's going to be C. The sum of the exterior angle of a regular polygon is always going to be 360 degrees. For a regular polygon with n side, each exterior angle is, now we know that the total amount of exterior angle is going to be 360 degrees. So if we want to find each of them, then we divide 360 by the number of sides, which is n in this case. So our answer here is D. In the triangle above, not drawn to scale, the angle CAB is equal to 30 degrees, which is this angle. And AC is equal to 50 meters, which is this side here. The length of BC in meter is, we want to find this distance, BC, all right? So all we need to do is to label the triangle according to what we have. We have an angle. The side BC is going to be opposite to that angle. And the side that we know is opposite to the 90 degrees, therefore it is the hypotenuse. So they want us to determine the length of BC. So we can see that opposite over hypotenuse, that reminds us of what? Sine of an angle. So we know the sine theta is equal to opposite over hypotenuse. So what is theta in this case? That's just 30 degrees. So we can say sine 30 degrees is going to equal to the opposite. What is opposite? That's just BC. That's what they asked us to find. Divide by what? The hypotenuse. That's just 50. Now they want us to find BC. Note that this is a multiple choice question, so you're not allowed to use a calculator. So they don't want an exact value. So all they want you to do is to transpose this to make BC the subject. And how can we transpose this to make BC the subject? Multiply both sides by 50. So multiply that side by 50 and this side by 50. But you realize that 50 will cancel out 50, leaves us back with just BC. And over here, all we have is 50 times sine 30, which can be written as just 50 sine of 30 degrees. Which one of these are that option? 50 sine 30 is A. That's it. In the diagram above, triangle APQ is mapped onto triangle OP prime Q prime. The transformation that took place is, let's observe it. So this is triangle OPQ. That's a triangle there. So we are comparing this triangle to the triangle OP prime Q prime over here. Now, here you can see if we look at point Q, what is happening to point Q? You can see that point Q have been rotated to this location there. And that rotation has to be 90 degrees because it rotated from the x-axis to the y-axis. And we know that the quadrants are divided into 4 quarters. So that has to be a rotation of 90 degrees there. So therefore, the transformation that took place is a rotation. Because if it was a translation, then it would just be a slide, right? If it was an enlargement, then the sides would be enlarged, the size of the figure would change. And if it was a reflection, then you would have a mirror line, and when you look in the mirror, you are reflected in the mirror, then you yourself look back at each other, right? So clearly this is a rotation. In the diagram above, not drawn to scale, AC and DC are straight lines intersecting at B. Angle ABC equal 125 degrees. The measure of the angle CBD is, let's highlight that angle. We want to find CBD, which is this angle here. Now clearly you can see that this angle down here is going to equal to this angle because they are vertically opposite angle. So clearly we know that our answer is going to be 125, but we could write it nicely to say that angle A, B, E is equal to angle C, E, D, which is equal to 125 degrees. And how we know? They are vertically opposite angles. Vertically opposite angles are always equal. So our answer here is 125. In the diagram above, not drawn to scale, PQ is parallel to TR, right? So we know that PQ is parallel to TR. And those arrows here suggest parallel. PQS is 45 degrees. The measure of angle QST is QST. We need to find that. We want this angle QST, which is this angle here. So let's compare angle QST with angle PQS. These two angles are what we call co-interior angles, right? And what do we know about co-interior angle? It is a pair of interior angle inside of a parallel line that sums to give 180 degrees. So what we can say here is to see that, all right, angle PQS plus angle QST is equal to 180 degrees. And how do we know this? The reason is that these are co-interior angles, all right? That's all we know. So what is angle PQS? That's just 45 degrees, all right? Plus this angle here, which is angle QST, that's the angle that we want to find, which is equal to 180. To find angle QST, it's just a matter of subtracting 45 degrees from both sides. So when you subtract 45 degrees from both sides, clearly you can see that angle QST is going to equal to 135 degrees. That answer is going to be C. A boy of height 1.5 meters stands 10 meters from the foot of a building, and the angle of elevation to the top of the building is 45 degrees. The height of the building in meters is, what do we want to find? We want to find the distance from here to here, which is the height of the building, right? We're going to call that distance h. So that's what we want to find, right? What is the piece of information that we know? We know that this boy stands 10 meters away from the building, which is this right angle, this side of the triangle right there. So this side is going to be 10 meters, all right? We know the angle of elevation from where you stand is 45 degrees, right? So we have that there, the 45 degree right here. So what that means, we know the height of the boy, which is 1.5 meters. So you can see that if we carry out this line all the way out, we know this height already of the building, which is 1.5 meters. So all we need to determine is this height right here of the triangle. If we can find that height, then it's just a matter of adding it to the boy's height to determine the height of the building. So let's call this height x. So if we call the height of the triangle x, then we can label it according to the values that we have. So we have an angle where x is going to be opposite to the angle, where 10 is, that's just adjacent to the angle. Which ratio is this? This is going to be tangent, right? So we know that tangent of some angle is always going to equal to the opposite length divided by the adjacent length. That's what we know. We can fill this information out. What is theta in this case? That's 45. So we know that tangent of 45 degrees then must equal to the distance x divided by the distance 10, right? Now we can solve for x because remember it's a multiple choice. They are not expecting us to give an exact value. So if we make x the subject, it's just a matter of multiplying both sides here by 10, right? So multiply this side by 10. Clearly you can see that 10 will cancel out 10, leave us back with x. And x is thus therefore equal to 10 times tangent of 45 degrees, right? And this distance is the height of the triangle there. So now that we know what that distance is, we now know what we can now determine the height of the building, which is h. So we can therefore say, all right, h then is going to equal to the distance of the boy, which is 1.5 meter, right? Plus the distance x. Well, what is x? X is just 10 tan of 45 degrees. So that's the height of the building there. Which of the option reflect this value that we have there? That's going to be option C here. 1.5 plus 10 tan 45 degrees. All right. The diagram above, not drawn to scale, shows that the angle of depression of a point x from z is 30 degrees. If x is 20 meters from y, the height of yz in meter is, so first, what do we want to find? Highlight what we want to find. We want to find this distance here, which is yz. All right, so let's just highlight that. I want to find that distance there. What do we know? We know the angle of depression. Do we know about angle of depression and angle of elevation? Angle of depression and angle of elevation, they are equal. So if this angle up here is 30 degrees, it means that the angle of elevation here is going to be 30 degrees as well. What else do we know? We know the distance from x to y, that's just 20. So all we need to do is to label our triangle according to the information that we have. So if we label, you can see that xy, which is the distance that we want to find, is going to be opposite to the angle. Likewise, over here, this side is going to be the hypotenuse because it is opposite to the 90-degree angle. And where 20 is, clearly that is just the adjacent side. So which one of the ratio fits this information? We have the opposite and the adjacent. So opposite, adjacent, that's a tangent. So we can see that tangent of 30 degrees is equal to the opposite length. What's the opposite length? That's just yz divided by what? xy, which is just 20. Now from here now, we can just transpose for yz by doing multiplying both sides by 20. Clearly, 20 will cancel out 20, leave you back with yz. So yz is going to equal to 20 times tangent of 30 degrees. Which option is that? 20 times tangent of 30 degrees is going to be B. So that's our answer there. A ship travels on a bearing of 45 degrees. In which direction is the ship traveling? Best way to do this is to make a representation, a quick sketch. So let's say that the ship was at a point here. Now, when we're dealing with bearing, the first thing that we need is an outline. So we need an outline, right? Because everything in bearing happens from north. So we have north, and we can just put on east side. All right, so this is east. Now, if the ship travels on a bearing of 45 degrees, from north to east, that bearing is 90 degrees. So this is 90 degrees, right? So we know that that bearing is 90. 45 is just half of 90. So the ship would travel here, which is halfway between north and east. So halfway between north and east will give us what? Northeast, right? So this is the bearing from north, the ship will travel 0, 4, 5 degrees. And that would take us to northeast. So which one is that? Northeast is just E. So that's it for that problem. A boat travels on a bearing of 180 degrees. In what direction is it traveling in? Now, this is straightforward. You have a point, right? So, you know, if a boat is traveling, first thing that you need is an outline, because you're dealing with bearing. Everything happens from north. So you can just put on your 4 cardinal direction, which is north. Continue the line down, you have south. And then going this way, you will have east. And then going this way, you'll have west. Now, they told us that a boat travel on a bearing of 108 degrees. So as you know, from north all the way around to south, that will give us a bearing of 180 degrees. So therefore, the direction in which the boat is traveling has to be south. That's it there. In each of the diagrams shows below, A prime is the image of A. Which diagram represents a reflection in the y-axis? So if we have a reflection in the y-axis, it means that the y-axis is the mirror line, right? So let's look at the first option here. The first option here, we have a reflection in the x-axis. The x-axis is the mirror line, so that's not the answer. For the second option here, this does not look like a reflection, right? So this is not the answer. Here now, we have the y-axis. So it's the y-axis here, which is the mirror line. You see A prime over there, and you see A. So if you fold it, you can see in the y-axis, you can see that it is reflecting. So it is reflecting in this line here. So C is our answer. For this one, in D, it looks more like a slide. That means it's a translation. So that wouldn't be the answer either. All right. So C is the answer there. In the diagram above, if the line y equal x is rotated anti-clockwise about O through 90 degrees, then its image is, so let's think about it. We have this line. We want to rotate it 90 degrees in an anti-clockwise direction. That means we want to go into this direction there as that arrow. So if we rotate this line from here 90 degrees, then it must drop into this quadrant halfway here, like that. Now, if it rotated, this line is what? This line here that I just draw would be the line y equal x, right? So when you rotate this, you can see because, and how do I know it will drop here? You can think about it logically. For the quadrant are divided into 4. So that means the angle for each quadrant is 90 degrees, like that. Like this. Now this line is halfway between y and negative x, right? So halfway between 90 would be 45. So if you rotate it from this point to the negative x-axis, that will give you a degree of 45. And if you rotate it halfway more, then that would give you another 45. So 45 plus 45 would give us 90. So that's a rotation of 90 there. And that will give us this line, which is just y equal positive x. Therefore, the answer is C. All right? Now, the answer could not be A. X equals 0. Another name for the y-axis is x equals 0. So therefore, A could not be the answer. Another name for the x-axis is the line y equals 0. So B could not be the answer. And note, they just repeat the equation here, y equals minus x. Can't rotate it 90 degrees and get the same line, so D could not be the answer either. In the right triangle above, tan theta is, we want to find tan theta. We need to label theta according to the information. So what do we know about tan theta though? We know that tan theta is going to always equal to the opposite length divided by the adjacent length. That's what we know. So if you label it according to theta here now, you draw a straight line like that, go across. That takes it to 12. So 12 is the opposite. Now clearly you can see that 13 is opposite to the 90 degree. So where 13 is the hypotenuse. Therefore, where 5 is has to be the adjacent. So tan theta is going to be this value, which is 5. So we could finish it. Tan theta is going to be the opposite length, which is 12, 12, divided by the adjacent length, which is 5. So it's going to be 12 over 5, which is B. A prime, B prime, C prime is the image of ABC under an enlargement by a scale factor 2. The area in square unit of A prime, B prime, C prime is, first we need to find the area of ABC. So we know that A for area of A, B, C is going to equal to half times the base times the height. What is the base here? Note that the first point here starts at 1 and it finishes at 5. So the base will be a difference between these two values. So it's 5 minus 1, which is give us 4. So B is going to equal to 4. It's going to be the height. The height is going to be the difference between 1 and 2, as you can see there. And that's just going to be 1. So H is going to equal to 1. So all we need to do is to plug in those values. So it's going to be half times B, which is 4, times height, which is 1. And what's just half of 4? Half of 4 is 2, and 2 times 1, that's just 2, right? So we can see that the area of triangle ABC is going to be 2 squared units, all right? Now they want us to determine the area of the image. So therefore, we can see that the area now of the image, which is A prime, B prime, C prime, is going to equal to the area of the object, right, which is 2 times the square of the scale factor. So the scale factor here is 2, and we must square that. So it's going to be 2 times 2 squared, which is 4, which is going to equal to 2 times 4, which is 8. And the area is going to be 8 squared units. All right, so our answer here is going to be C.